Okay. So determinants is an important chapter. It's very easy. Most of the questions are asked based on properties only in determinants chapter. So we have discussed about matrices already. Matrix is a collection of data in rows and columns where all the number of elements in each and every row is equal, and it is the same with columns. And as we know, matrices do not have any definite value. But when we talk about matrices, so determinant, then we represent the elements in between two long straight lines, vertical straight lines. Okay, instead of large brackets. Now this will have some solution, and this will give a certain value. This will be a certain value, a definite value. It can be number, can be any expression polynomial, okay, based on what the elements are. So an expression related to each square matrix is known as a determinant of A. It is denoted by, can be denoted by drawing two straight lines, two vertical straight lines, or delta. Okay. Now we will be able to only find out the determinant for square matrices. Square matrices means number of rows and number of columns has to be equal. So only determinants will exist for square matrices. Arrangement of numbers is known as a matrix. Hence, it has no definite value, while each determinant has a definite value. Determinant of n rows and n columns is known as a determinant of order n. If any matrix is not a square matrix, we will not be able to find out its determinant. Now let's discuss about finding out the determinant of singleton matrix. As we know, in a singleton matrix, there is only a single element. So the determinant of the same matrix will be the element itself. Okay. For example, let's consider an matrix -1. So its determinant will be -1. Let's consider element a single matrix having -half as an element. So its determinant will also be minus of half. Because for singleton matrices, the determinant is same as that of the number. Now please do not confuse this representation of determinant as this is an absolute function or modulus function. No, this is not the same. This is just a determinant. Okay. This does not mean that modulus of -1 will become +1. No, because it's not a modulus. It is representing determinant. Is that clear, everyone? Yes, please
Yes,
respond.
sir.
Okay, let's now discuss about the value of determinants of order 2. So whenever we have any matrix of 2 by 2 order, so how we'll find out the determinant? We'll multiply these elements A1, A11, and A22 minus, we'll subtract the product of these two elements. Basically this. So this is how we are going to find out the value of any determinant of order 2. Let's take an example. So 5 into 3, 15, minus 4 into 2, 8. So 7 is the determinant. Any doubts, anyone, about finding the value of a determinant of order 2 matrix?
No,
Okay, let's move ahead then. Now let's discuss about finding out the value of a determinant of order 3. Okay, so we have to consider that, let's say this is the 3 by 3 matrix. So we'll have to multiply the element. Like, we can choose any. First step is to choose any row. You can choose any row, first, second, third, any row, or you can choose any column. You have to only choose one. a row or a column. Okay, so let me write or. Then multiply elements of that particular chosen row or column with their cofactor and sum them. Now, these are the steps to find out determinant of any determinant of any order. To find determinant of any order. Okay, so let's try to apply these steps on the 3 by 3 determinant. So this is the determinant. Now let's choose any row or any column. So we have chosen the first row conveniently. So we'll multiply the element, okay, A11 is the first element, into the cofactor of A11. Now, if you remember how we can find out the cofactor? Cofactor of Aij will be minus 1 raised to power I plus j into minor of Aij. Now, minor is how we can find out the minor of any particular element. So if there is this element situated somewhere in the determinant, so we will have to exclude. What we need to do is that we need to exclude the respective row and the respective column of where the element is present, and we'll have to find out the determinant of remaining, like, right? So let's say here, for finding out the cofactor of A11 element, we'll exclude this respective row and respective column. Now we'll find out the determinant of the remaining, which is this. Okay, this is the minor, and also to make its cofactor, we'll have to multiply with minus 1 raised to power 1 plus 1 into minor, which is this. And now the same, sorry. Now the same process repeats for the second element here also, A12 into minus of 1 raised to power 1 plus 2. And the determinant of the remaining, so this will be this. So basically this is going to become this formula only. Now you will be able to understand why there is a negative sign with A12, because the sum of 1 and 2 is odd. So minus 1 will get multiplied by 3 times. Minus 1 plus 1 into minus 1 makes it a minus 2. So that is why there is a negative sign. There is a negative sign here in the formula. I hope you are able to understand. If you have any doubts, you may ask. Any doubts, anyone?
No, sir.
Sure.
This is why the negative sign is there, because its cofactor will be negative into the minor. Okay. So let's simplify things for us. Okay, we'll do that later. I was thinking to represent the determinant in terms of minor. So we'll do that later. Anyways. So this is how we find any determinant of any matrix having any order. Okay. So this is the formula. You can remember it. And now please don't cram it. Just understand the method, that if we have chosen this particular row, then this is the formula that is going to be. What if we have not chosen this row? We have gone with some other row or column. So let me write for the Let me write the formula for the same. Let's say we are going with the first column. So A determinant, the first element into its cofactor. Now A11, 1 plus 1, so it will have positive sign only. Now the determinant of remaining elements. Minus of A21. Why minus of A21? Because 2 plus 1 is an odd number. So a minus 1 raised to power odd number will make it a negative into the second element, to the vector element and its cofactor, including the row and the column. So that will give us A12, A13, A32, and A33 plus A33. Sorry, A31. Now why plus A31? Because 3 plus 1 is a is a even number. So minus 1 raised to power even number will make it a positive term. So now the determinant of the remaining A12, A13, A22, A23. So similarly, we'll be able to find out the different formula of determinant using the same method, right? Any doubts, anyone?
No, sir.
Please observe and read the slide again. 1 minute.
Yes, sir.
Done reading?
Yes, sir.
Okay. So first question. So we have 2 by 2 determinant whose value is given to us. We have to find out the value of x. There are options. So try to solve this determinant. So we'll have to multiply these element and we have to subtract the product of these elements. This is given equating to 0. Let's now solve for it. X square minus 4x plus 3 minus x square plus 2x equals to 0. X minus x square plus x square cancels each other. 3 minus of 2x is equals to 0. 3 is equals to 2x. 3 by 2 is equals to x. Option number B is the correct answer. Any doubts, anyone?
No, sir.
No doubts? Simply a cross multiplication, then subtraction, basic algebraic solution. Okay. Let's now discuss about a topic which we have already discussed about. Let's say there is a matrix Aij, be a square matrix of order n, then minor of Mij. Then minor Mij, this is the denotation, this is the symbol of any minor for any particular element, is a determinant of a square matrix of order n minus 1, which is obtained by leaving the ith row, the jth column. So whatever we are discussing about whichever element that we are discussing about. So we have to exclude its row and exclude its column. Then whatever is left, its determinant will be our minor. So let's say for A1, we have excluded this row and its column. Now the remaining element's determinant will be the minor of first element. This is the minor of A2. So after excluding the row and the column, B1, C1, B2, C2. The minor of this particular element is in the second row, first column. This is the minor of third row, first column element. Please read the slide. Any questions, anyone? Any doubts?
No, sir.
Please read the slide. Done? Understood the concept?
Yes, sir.
Basically excluding the respective row and the respective column and taking the determinant of the remainder. Simply, if we talk about the cofactor of any particular element, now remember that minus and cofactor do not exist for a particular matrix. They are taken in consideration with particular element. So we find out cofactor for any particular element, and we find out minus for any cofactor element, for any particular element. So cofactor of any element will be simply uh, multiplication of minus 1 raised to power I plus z into the minor. So we have already discussed about minor, what is a minor of any particular element. Simply multiply with that with minus 1 raised to power I plus g to give that a sign. Okay, it gives a sign, positive or negative sign. So for I plus j being even, will makes the cofactor as equal to the minor. I plus j being odd will make the cofactor of opposite side as of the minor. I'm saying opposite sign, not negative necessarily. Okay. So let's try to find out and let's try to represent this particular triangle. Now I have done this blunder. Anyways, so let's try to write this particular triangle. Let's try to write the determinant in form of its cofactor. So we are finding the determinant of cofactor. So this will be C11, C12, C30, C21, C22, C23, C31, C32, 33. Let's now try to represent them in the form of minus. So M11, because the sum is even. Sum is odd here, even here, odd here, even here, odd here, even here, odd here. So here there will be a negative sign. There will be a negative sign here also. Positive sign, negative sign here also. Positive sign, negative sign here also. Positive sign. Are you able to understand why particularly these four elements are having, these four minors are having negative signs? Is everyone clear?
Yes, sir.
Yes. When we talk about any matrix in 2 by 2 order, let's say there is any matrix. Let's now find out its cofactor. Presenting them in the form of minus. So odd here, sorry, even here, odd here, odd here, even here. So this is equal, negative sign, opposite sign, same sign. Simple. As simple as that. Is that clear, everyone?
Yes, sir.
Yes. Rishi, do you have any problem? Why did you join late? All good?
Sir, yes, sir.
Okay. Another example. Minus and cofactors of minus 4 and 9. Okay, minus are going to be positive. So we are better to ignore those options which are having negative sign. Okay, but we are not sure whether minor. See, minor will not always be positive. They will be the determinant of something. That's the only thing which we know. So it's not like that minus cannot be negative. Okay. So let's simply solve them. Nice. Let's simply solve them. So minus and cofactor of minus 4 and 9. Okay. So for finding, let's find out the minor first. Exclude the particular column and the row, determinant of the remaining, and into minus 1 raised to power. This is the second row, first column. So 2 plus 1, post negative sign. Minus 2 into 9, minus 18, minus 8 3 is 24. This becomes 6 3 is 4 is 7, 42. Minus into minus 42. This becomes minus minus plus 42. So the minor of minus 4 is definitely 42. Now let's find out. This is the cofactor, sorry. This is the cofactor, and the minor is this. Okay, let's now find out the minor of 9, excluding the row and the column. Minus 1, minus 2, minus 4, minus 5. This is the minor. And minus 1 raised to r 3, 3, 6. So minor and cofactor will be equal. Minus 1 minus 5 plus 5 minus into minus 4 minus 8 plus 8. Minus of 3 should be the answer. Minor and cofactors are equal. Okay, so this is the minor and cofactor both. So this should be minus 3 and minus 3. Okay, for minus 4, minus 42. Minus 42 is the cofactor, sorry, minor. So minus 42 and plus 42. And minus 3 and minus 3 are the minus. Clear. B option is the correct. Any doubts? Please read the question and the solution. If any doubts, ask. Red.
Yes, sir.
Minus 2 minus 3 minus 42 plus 42. Let's now discuss the properties of a determinant, and these are really important, very important. So the value of the determinant remains unchanged if rows are changed into columns and columns are changed into rows, and this happens when we take adjoint, when we transpose any matrix. Basically, this is written that the matrix determinant is equivalent to its transpose determinant. The rows has made now columns. Row, second row has become the second column, third row has become the third column. This is the property. Let's take one example of it. Say this is the determinant 2, 2, 1, 4. Okay, so its value is value is 2 into 4, 8 minus 2, that is 6. Now let's take its adjoint, transpose 2, 2, 1, 4. The transpose determinant is 8 minus 2, 6, same. So that's why the properties stays true. Any doubts, anyone? No doubts? Should I repeat? Transpose of any matrix is when we interchange the rows into columns and columns into rows. Basically, if you just interchange if you just make rows into columns, so uh, the columns will itself become the rows. So you just have to consider first row and make it a first column. Second row, make that the second column. Third row, make that the third column. So basically, it's the transpose of the given matrix. And the property says that the determinant of the matrix and the determinant of the transpose of the matrix will be equal. Clear, everyone?
Yes, sir.
Yes, sir.
Next property says if two adjacent rows, adjacent means जो पास वाली होती है, like the nearby. If two adjacent rows or columns of a determinant are interchanged, then the value of the determinant so obtained is of the opposite sign of the value of the original determinant. So if you, let's say what is done here, they have interchanged the first row and the second row. So there will be a negative sign here. The sign of the determinant will change, will be opposite, and there will be no other effect on the determinant. This is the only effect. So let's take an example, same example. 8, 2, 2, 1, 4. Let's interchange the first and second row or the column. Let's interchange the columns. So second column becomes the first column becomes the second. So now the determinant for this was 8 minus 2, there was 6. This time it is 2 minus 8, which is minus of 6. So see, there is a change in sign, right? So this is what the property says. And it is applicable for the interchange of two adjacent rows, or it is the same with interchange of two adjacent columns. Clear, everyone?
Yes, sir.
Where is this 8 coming from? My God. Next property. If two rows or columns of a determinant are identical, means if they are same, then the determinant value is 0. So if let's say you can observe that this first column and second column are exactly the same, then the determinant will be 0. Let's take an example. If this is 2 2 and if this is 2 2, the first two columns are equal, so its determinant value is 0. You can find out that 4 minus 4 will become 0. Let's apply it here in this format. Now the first row and the third row are same. So let's try to find out its determinant. 2 into 4 minus 1, 3. Minus 1 into 4 into 2, 8 minus 2. That is 6. Plus 2 into 4 minus 4, 0. 4 minus 4, 0. So 2, 3, 6 minus of 6 equals to 0. So if two rows or two columns are equal, then the determinant's value is coming out as 0. Is that clear, everyone? Clear?
Yes, sir.
Yes, these properties are very important. Please understand them properly. Discussing the next property, each element of a row or column of a determinant is multiplied by a constant k, then the value of the new determinant is k times the value of original determinant. So if you are taking common, basically if you are taking common, if you are dividing a particular row with k, then if you're dividing the first row with k, then you can multiply k raised to power 1 with the original determinant. Okay. And if you, so simply, let's we write it here like this. And if you divide k from two rows, then you will have to multiply k square into the remaining whatever is there, this one, into the determinant of A11, A2, A1 to A3, 1, 3, A2, 1, something like that, right? So what we have taken common, k from this row, okay, k is written, and k, another k from this second row, so k again. Okay, so we may say it like this, if k is getting multiplied with follow the matrix, means all three rows, है so k will get multiplied with whole of the number of rows into the determinant of A. This is for matrix 3 by 3 order. What if any matrix is of 2 by 2 order or 3 order? So we'll simply write order instead of 3 here. So this is another property which we are going to study next after some time. So whenever we are taking anything common from a single row, then we'll have to multiply that particular value with the complete definite value of the remaining determinant. If we are taking common from two rows, then the power will be 2. Understood, everyone? Should I repeat the fourth property? Yes, you may ask, you may tell me, should I repeat or should I move ahead?
No, sir. Then continues.
Okay, but still for my satisfaction, I'm going to do it. Let's consider a
Okay,
2 by
sir.
2 matrix. Yeah, and if we have to multiply any scalar, any constant with the with the determinant, so we can multiply a single degree constant with one row or one column itself. So let's say we can multiply it with one row only, and its existence is finished. For us to enable to multiply it with two rows, we'll need two k's. So now we can multiply k with the second row also. So this is how things work. Okay. This is how we can take common from any particular row by simply multiplying it with the remaining. So if we have taken common from the first row, k, okay, k is written here, and also k from the second row. So k into k becomes k square. Now is that clear, everyone?
Yes, sir.
Okay. So let's move ahead then. Fifth property. If any two rows or columns of a determinant are proportional, then its value is 0. Earlier, what we have discussed about that two rows or two columns getting equal or identical, then also the determinant was 0, even if they are proportional. Proportional in the sense k is some constant, any integer, or any real number. Then non-zero, k is a non-zero real number. Then the value of the determinant will be going to become 0. Let's say, for example, 1, 2, 3. This is 2, 4, 6. This is 0, 1, 5. Then its value will be 0. Why? Because the first row and second row are proportional. So let me prove it to you that I can take 2 common from the second row. Is everyone agree? So I'll take 2 common from the second row. So 2 by 2 becomes 1, 4 by 2 becomes 2, 6 by 2 becomes 3. Now, as per the property that we have discussed earlier, this have two rows equal. So 2 into 0, its determinant value will be 0. Hence, the LHS is equals to RHS. Now, is that clear, everyone? Why proportion? If there are any proportional rows or proportional columns, means proportional means that these the ratio of these two elements are equal, like 1 by 2, 2 by 4, 3 by 6. They are all 1 by 2. They are all 1 by 2. Clear, everyone? This is what proportionality is. Any doubts? Any? No doubts?
No, sir.
Okay, let's now discuss for the next property. Each element, basically, if anything particular getting added with a whole row, then we may write it separatively. Okay? And even if there is nothing with a single element in that row, we can consider that as 0. So instead of writing that particular C2, we'll write 0. Okay. So this is one thing to understand. Like, let me write it here. If there is A, B, C, D plus F plus E plus G plus H plus I, यहाँ पे S, S, B. If this is the determinant, we can expand it with writing all the rows similarly, but taking first term only from the addition, and plus all other rows similar, and the row having addition, we will take the second term only. Okay, any doubts, anyone? This is how we can expand. So let's now reread it. If each element of a row or column, okay, of a determinant is the sum of two or more terms, then the determinant can be expressed as a sum of the two or more determinants. Clear? If there was nothing getting added with D, so instead of writing F here, simply consider 0, 0 getting added with D. And note, okay, is this point clear, everyone? Clear or should I repeat? Hello. So let me repeat. Basically, the property is saying if there is any row or column, let's consider the second row, second column this time, is there in form of some sum of particular terms, and so we may expand that particular determinant in how many terms are there accordingly. So we may expand this in three matrices, considering there are three terms, there are three numbers getting added in the second column, or we may expand it twice, considering that there are two elements only getting uh, getting added in the second row. Okay, you can do accordingly. ATS plus taking the first element this time plus now ATS and PQR remains the same. Taking the second element this time, C, E, and F plus G. So this is how a determinant can get expand. Any doubts, anyone? No doubts, I guess. There's one more property, very important. And this is an important technique. Whenever while solving determinant of any matrix, try to pick that row or column which has maximum number of zeros. So let me give you an example. So in which row there are, or like in which row or which column there are maximum zeros. So in the second row, you can see in the second row there are two zeros, but in the third row there are two zeros. So we may pick any. Let's pick the third row to find out the determinant. So first of all, the first element of third row, 5, into the multiplication of its cofactor. So its positioning is first 3. So even positive. Determinant of remaining remaining elements, so excluding the row and the column, 5, 0, 1, minus 1, plus or minus whatever, 0 into something, plus minus 0 into something. So they will eventually become 0. So it doesn't, we even don't care about the sign, about the value that is there inside. So the B's determinant is 5 into minus of 5 minus into 1 into 0. So minus 5 into minus 5 into minus 5 becomes 25. So this is how easy it is to find out the determinant with the maximum number of zeros in that particular row or column that we are considering. I hope that is clear. Okay. So if each element of a row of a determinant is multiplied by a constant k, then added to the corresponding elements of some other row, then the value of the determinant remains the same. So what is happening here is he there's the operation called the operation. Here third row is getting added with the multiplication of some other row, which is the second row, sorry. Now, after doing this operation, we have basically operated the row number 3. We have modified the row number 3. How we have done so? We have added the row number 3 with the row number second after multiplying the certain constant, the second row elements. So that's how it is being done. And this is the operation that is there acted on the third row. But the property is that the value of the determinant will remain the same after that operation also. So this property gives us freedom and liberty to operate on particular rows or columns. Clear? Now this is very important. This property gives us the liberty to do operations on particular rows or maybe on maybe on columns also. It depends on our intention and objective. This one more property. If each element of a row of a determinant is 0, then its value is 0. Okay, let's say 0, 0, 2, 4. Its value will be 0, or 0, 0, 2, 4. Its value will also be 0. So if a whole row or a whole row or a column is becoming 0, so definitely its determinant will be 0, because for finding out the determinant will pick this, and 0 into 4 minus 0 into 2, 0. 0 into 4, 0 minus 2, 0 minus 0 to 2. That is also 0. This is the eighth property. Next property says, if R rows or R columns become identical when A is substituted for X, then X minus 1 A raised to power R minus 1 is a factor of the given determinant. So this is important and complex to understand. Let's consider a matrix of order 4, 2, 2, 1, 2 by 2 order determinant. So when A is substituted for X, so now this has become R rows or R columns has become identical when A is substituted for X. Okay. So there are particular variables in the determinant known numbers. What this property is saying is that if there are R rows or R columns, so let's say there are R rows that are identical, means there are rows that are same. And when A is substituted for X, so in those R rows, there was a particular variable which got substituted, now has become A. Now the new determinant that will be found without identical rows or columns will have a factor x minus of A raised to power R minus 1, where X was the variable earlier, A is the substitution, is the new substitution, and R is the number of rows or the number of columns that are there identical, that are there same. Okay, is this property clear? Is the ninth property clear, everyone? Okay, let's move ahead then. The sum of the products of elements of any row or column of a determinant with the cofactors of corresponding element of any other row is 0. So this is basically saying that the sum of products of elements of any row of a determinant with the cofactors of corresponding elements of any other row is 0. So basically, if we find out uh, its cofactor, and multiply it with any corresponding elements of the first row or the second row, sum is going to become 0. So this is what it is saying. Even if there was C21, C22, C23, then also the sum was going to become 0. This is what the property is saying. The sum of the products of elements of any row. Basically, this is the definition of determinant, that how determinant is find it out. We have already discussed about it, that the multiplication of the element into cofactor for any particular row or column, that will give us the determinant. I hope that is clear. Let's solve this example. Now, in this example, we can see there's a pattern. 13 minus 14, 1, 16 minus 17, 1, 19 minus 20, 1. And difference here is also 1. So why not let's simplify the numbers instead of bigger numbers, because if we go on and solve this determinant right now, we have to solve for big multiplication like 17 into 21, 18 into 20, 19 into 17. So instead of that, let's make it simple. So what we'll do, we'll apply operation in row number 3. We'll subtract the row number 3 element from the row number 2nd. Now 15 minus 14 here, 1, 18 minus 17 here, 1, 21 minus 20 here, 1. Okay, we can also observe the same pattern between row number 2nd and 1st. And remember that we can apply a single operation on a single row only once, okay? So now let's apply the operation on 2nd row. We will subtract the 2nd row. We'll subtract the first row from the 2nd row. Okay. So the first row remains the same because it's not getting operated here. And third row will also remain the same. 14 minus 13, 1. 17 minus 16 becomes 1. 20 minus 19 becomes 1. Oh my God. There are two identical rows. So its determinant should be 0 as per the property. C should be the answer. Yes. It is the answer. Clear, everyone? Is that clear?